Good afternoon. Many of you will be forgiven if you're wondering why a group of archaeologists and palynologists in Belfast are looking at Tephra. Ireland's not known for its volcanoes, although we do have some. My presentation, unfortunately, is full of graphs, so I'm taking this opportunity to show you a photograph of a ring dike, which is the remnants of a volcano, one of the last episodes of volcanic activity in Ireland, dating to about 58 million years ago. So it's of great interest to geologists, but not terribly useful from a Tephra chronological point of view. But what Ireland lacks in volcanoes, it makes up for in bogs. Specifically, this type of bog, a raised bog, which forms in lowland areas, and we can thank the amount of weather we get in Ireland for these environments. So they're wet environments. They're great for preserving proxies such as pollen, plant macrofossils, and also tephra. They've been forming since the late glacial, so we've got 15,000 years worth of sediment in these environments. The late glacial material and the early Holocene material is usually influenced by groundwater, so you get material being washed in. But from the early to mid-Holocene, the bogs tend to become raised above the local water table, and they're umbrotrophic, which is to say they're getting the moisture from clouds, and any oligoclonous material is coming in from the atmosphere. So the focus of my study is on the middle to late Holocene, because the bogs are really easy to work with once they're in this umbrotrophic phase. Like Christy, I'm also quite lazy, and we can easily sample this material. We don't have to worry about separating the tephra out from minerals. Now, the field strategy we employ is completely different to what was described in the field yesterday by Marcus and John. When we go out, we either core the bog, or if we've got an open section, we take column samples. And that is effectively it. Now, I should say, if you look really closely, really closely in about there, you won't see the White River 8860 ash, because you can't see the tephra in the stratigraphy. Hecla 4 is about down here. We know this because this is one of the most studied bogs in Ireland. This is a section in Sluggan Bog. All we do is we go out, we collect the samples, we bring them back to the lab. We can record the stratigraphy of the peat in the lab. And then we burn the ash. We subsample it, and we burn it, and we look for the tephra. It's as simple as that. Jonathan Pilcher and Valerie Hall have been doing work on volcanic ash, particularly fine ash, in Northern Ireland since the early 90s, so shortly after the work was done by Andy Dugmore in Scotland. And by the mid-1990s, they were identifying the main tephra layers, and they were using radiocarbon to get wiggle-matched ages for some of the undated prehistoric eruptions. So we've got historic eruptions represented from Hecla and Erephiokal, from Iceland, and some prehistoric eruptions that are dated by radiocarbon. And a typical Tephra stratigraphy would look like this. Now, I'm presenting all the diagrams in terms of the number of shards. It's more common these days to quantify them in terms of grains per cubic centimeter or per gram. But realistically speaking, you can take two cores from site, and you will not get the same numbers. So it's not particularly meaningful. The number or the concentration of shards is not especially meaningful. I don't have the loss and ignition data for all the sites, so that's why I've chosen to present number of shards. So this is the stratigraphy, a typical stratigraphy, and the early work focused on the big tephra layers, the ones that were most prominent. These were geochemically analysed using wavelength dispersive spectrometry, and in some cases the tephras were morphologically characteristic. For example, Erephiokal is represented by very fine shards, generally quite platy, and with a slightly pinkish tinge, quite unique for the tephras that we're finding in Ireland. Whereas Hecla 1104 and Hecla 4 are much more vesicular, and they tend to be larger grains as well. And then we also see brown tephras, so we distinguish between the colourless tephras and the brown tephras. And we see this type of stratigraphy is repeated site after site after site. Sometimes certain tephras, such as Erephiokal, are not present in certain regions, such as the Midlands. So we can see differences between the north, the west, and the Midlands of Ireland, despite the fact that it is a very small area. After the main Tephras were identified, Valerie and John started working on the smaller, the less numerous Tephras, including, for example, the GA485, as it was named after Gary Bog, which is nearly always found underneath the 860 Tephra. And they would also point out here the Microlight and the GB4150, also a Catalan Tephra, which are found here in Gary Bog, but are more commonly found underneath a much more prominent spike of brown glass. So we see this triplet of Tephras in most sites, except the far northeast, where the BMR 190 is absent. And again, on a Tephra stratigraphical basis, we can be pretty sure of what we're dealing with when we see the Tephra stratigraphy, before we even get geochemical analyses. I'll just point out that in some sites, as I said, we can use the Tephra stratigraphy to have a very good guess at what the Tephras are. This is a Tephra stratigraphy from a bog in the Irish Midlands, where the numbers of shards are absolutely pathetic compared to what we're used to finding. Nevertheless, the central Tephra, the colourless one, the Microlight Tephra, as it is known because of the presence of microlights, a relatively rare phenomenon with the Tephras we find, we can see that this is present in this particular layer. So the fact that we've got a Tephra with microlights sandwiched between two brown Tephras would suggest we're looking at the BMR Microlight GB4150 triplet. And I later got analyses from a larger sample corresponding to the top one that confirmed this identification. So the numbers of shards are not necessarily significant. Some other anomalies that we've noticed. Initially, I didn't know this until I was actually putting together information for the abstract for this talk. I was pulling together information from Gary Bog. Valerie and John had identified minor spikes of Tephra above and below the Hecla 4 Tephra. They had analysed these, and the chemistry of the ash turned out to be identical to the Hecla 4 ash. Now, they didn't publish these because they thought this is probably a taphonomic issue. Somehow the shards have moved up and down from the main depositional layer. So this was buried in the records, basically. And it wasn't until I was going through the records that I spotted this, and it rang an alarm bell. Because some years before, I had been working on a floodplain deposit in the north of Ireland, and I had identified a triplet of Tephras. I had analysed each of them and found them all to be Hecla 4 type. So the stratigraphy looks like this. At the time, I didn't know what to make of it. The fact that we've got clear spikes here was suggesting that it wasn't simply redeposition, reworking of material. But this was a floodplain environment, so I couldn't completely rule that out. But we're seeing the same triplet in Gary Bog, which is an umbrotrophic bog, a completely different type of system. I don't know how to explain this, because we haven't looked at it in any detail, but it does lend some credence to the fact that this might be a real phenomenon. Certainly it's something we're going to have to look into in a bit more detail. So 10 years after John and Valerie had started doing Tephra work, they put together a list of all the main Tephras that they had identified, and they published it. So there's 20 geochemically typed Holocene Tephras, 10 of which were known to be Icelandic events, some of which were historically recorded, really, really good for doing pollen studies, etc., on the peats that they were found in. But this wasn't the whole story, because there was a lot of data that weren't published because they were thought to be poor data. The two Hecla 4s, for example, the two other Hecla 4s, for example. I also mention at this point that a separate study was carried out by Chambers et al. On Inishmore off the west coast of Ireland, where they identified 12 Tephras, 7 of which had not previously been reported. There were some similar issues that they thought they had multiple episodes of the same eruptions. Now, at the time, thought most of the Tephras, as far as we could tell, the Tephras were coming from Iceland. It's our nearest active volcanic source. So it was assumed that Tephra would only have come from here, with a possible hint that some material was coming from Jan Mayen. Chambers et al. Linked some of their andesitic Tephras to Jan Mayen without having any really good comparative material. And in 2011, Swindles et al. Looked at the distribution of Tephras and how often Tephras were reaching different parts of Europe. And it basically collated all the information that was available from published records at this time. So you can see how Ireland compares in the number of Tephras, the distribution of Tephras, compared to Northwest Europe. What was really surprising was that Ireland has a much higher concentration of Tephras. Models would suggest that Tephra from Icelandic events should be going mainly towards Scandinavia, but Scandinavia is underrepresented compared to Ireland. I guess this was resolved. Oh, no, I'll come on to the next bit. Some of the other work that was going on in the meantime was the work we began doing on the ice cores. So specifically looking at the die 3, grip and N-grip cores, and targeting particular events for various different reasons. In some cases, we wanted to find historic Tephras that would help us secure the ice core chronology. In other cases, we wanted to get ice core dates for prehistoric eruptions, so improve the dating of the Tephras. And in other events, we wanted to look at potentially the impact of the eruptions. So these were the list of target events that we went for. Subsampled ice above and below where we would have expected the Tephras to be on the basis of the acid records. And what we found were some of these, but notably the only Icelandic Tephra that was present was the only Icelandic Tephra that we found was the Arafiocal 1362 Tephra. Other sources included Katmai, Changbaishan in China, which was a nice surprise, and Aniakchak. Contributing further to the debate about whether the big acid layer was due to the eruption of Thera or Aniakchak. Our major element data certainly suggests we're looking at Aniakchak. But we didn't just have one Aniakchak, we had two Aniakchaks. One of them a major one associated with the acid layer, and another one slightly earlier. Amongst the other samples that we looked at, we found 7 other Tephras being defined by more than one Tephra shard, that we couldn't identify to source, and 2 other samples that had individual shards, which were dismissed basically as potentially background Tephra, despite the fact that we're far removed from volcanic sources here. We're at over 3,000 meters altitude, and the chances of random Tephra getting in, I would argue, are relatively slight. So now, in the meantime, Sean Pine O'Donnell was working in Newfoundland, was identifying Tephras there, was collaborating with people in Edmonton, and the penny dropped. The 860B Tephra that we'd been finding all across Europe was actually the very same as the White River East Tephra across North America. So now we knew that material wasn't just coming from Iceland, that it was crossing the Atlantic and potentially being distributed over wide parts of northwestern Europe. The diagram down here shows the black dots where the 860B has been found. The white dots are where the Tephra wasn't found. It's the absence of the Tephra rather than we just don't know. And incidentally, I'll also point out that the Tephras that were previously assumed to be from Jan Mayen are now almost certainly known to be coming from the Azores. So Stefan Vestergaard has a student working on Azores material, characterizing the material on the Azores itself. And it does look as if Azores material is reaching at least the west coast and the north coast of Ireland. So that made us, it opened the floodgates, made us look through our data sets and find out what else have we got in there that might not be Icelandic, that might be coming across the Atlantic. Well, first of all, we've got other 860B type Tephras. There's 2 of them recorded, 2 others recorded at Sluggan Bog. Sluggan SLU5 is now found, has recently been found at a second site at Fallahogie Bog by Heidi Ray, indicating that we have a Tephra that isn't just random, it's been found at 2 different sites at the same time, dating roughly to about 1600 AD. And another one which is a bit more uncertain because it's only found at Sluggan itself, dating to about 1100. So this one is mixed in with some other Tephras. So a suggestion that there might be another event from Mount Churchill, even though there's none reported. Another Tephra that we found interesting was the Moore T12 Tephra that had been reported by Chambers et al. They had assumed this must be Icelandic, and they had compared it to Icelandic material. It was fairly close to a Hekla rhyolite, And they compared the two different Hecla deposits, and they assumed that it probably most closely correlates with the Hecla 5 eruption. So they said it is a Hecla 5 eruption. But the data weren't quite right. It wasn't a perfect match. And in fact, when we plot their 4 points against some Mazama data, we find that this is a much better correlation. So I would suggest that Mazama is reaching Ireland, or at least reaching the west coast of Ireland. Hoping to get more of this material to look at this in more detail. Another population that wasn't reported was a minor component of the GB4182 Tephra. The Hall and Pilcher paper included the main population, all 7 analyses, whereas the minor population was not reported. But the minor population gives a very good match with Aniak-Czech andesite rhyolite material. And is comparable also then to the material that we're getting from N-Group as well. The date of the GB4182 is around the time of Aniak-Czech. So again, I would suggest that even though we don't have many analyses, the Tephra is occurring at the right time and matches Aniak-Czech. So here we've got another potential correlation across the Atlantic. Getting into even more fine detail, we've got three analyses from a Tephra that I looked at for my PhD. I had a site, I was hoping to find Hecla 4, wasn't finding Hecla 4, so I was analysing some peaks to see if I can get any correlation with other Tephras in my other sites. I got 3 analyses from this particular Tephra, all fairly consistent with each other, but they didn't match anything in our database, and I just gave up. It was going to be absolutely no use from a dating point of view. And it wasn't until we started collating information from the North American papers that I realized that we have got a good correlation with one of the Mount St. Helens Y Tephras. Presumably, if this is real, it will be Mount St. Helens YN, given the magnitude of that particular event. The dating, the interpolated date from my site, 1900 BC. So it's spot on in terms of the suggested date. Overall, this is how it's looking so far from going through the analysis, from going through the database, looking at the outliers, the forgotten shards. I would suggest that we have several events represented. Admittedly, the Mount St. Helens W potential is a little bit scrapey. There's one analysis, and it's mixed in with 1510 Tephra. It's in the right time frame, but it will be like looking for a needle in a haystack because we have a lot of Icelandic Tephra coming in around this time. Now, some of you may scoff at the small numbers of analyses here and say these are not significant, not usable. I know some of you think that, but I would argue that we shouldn't be looking at the number. These are numbers of analyses. These are not telling you whether it's a Tephra layer or not. And if we were to go back to the Tephra Stratigraphy, we can see this is the 487, the one we have 3 analyses for. This is a clear Tephra peak. Right? So it is bigger than the Microlight and GB4150 Tephras. It is not an insignificant layer. These are examples of the Tephra shards. And the reason it is so difficult to get analyses from these, the reason why we don't have a big data set, is because one, they're fine material, they're platy, they're difficult to get analyses from, and very likely most of the material, because it is small, was sieved away when we were preparing the material for mounting for microprobe analysis. So, and the other factor, of course, is that it didn't correlate with anything, so I simply didn't put the effort in to getting more data. But it is a clear Tephra peak. The potential Aniak-Czech correlation, similarly, is down here. Again, the shards are more numerous than the Microlight and GB4150 Tephras, but they weren't correlating with anything. And again, they're very, very fine shard. Look up here, there's a shard here and a shard here. They're almost, if you move the stage on the microscope too quickly, you will miss them because they are so difficult to see. So there are reasons why we don't have large numbers of analyses for these Tephras. We can resolve that because the bogs are still there. We can go out and core the bogs again, and we can look for these Tephras and do more work on them. We have a different story when it comes to looking at the ice cores because we have a finite amount of ice. In some cases, we will have half pint to a pint of water to deal with, meltwater. But the numbers of shards we're finding are generally very low in concentrations, much lower than in the peat bogs. And more recent work that we've done has been looking at ice from Neem and Tunu in northern Greenland. And again, we've targeted specific events. We went back in to find the Changbai-shan and 860b Tephras, because we wanted to be able to correlate the different ice cores. And we also looked for other events, Elgia settlement, because these would help us tie in the chronologies with GISP2 as well. And the Katla 822 eruption. This is an eruption that is dated by dendrochronology, and if we could find Tephra from it, it would also help secure the dating of the ice cores. We did find Tephra, dating to the right time, and this is it. This is it. It is the worst type of Tephra we could possibly get. It's so small. We have polished, and we have polished, and we have polished this slide, and still we have microns to go before we even get down to it. And even if we do manage to expose the Tephra, we don't know if we'll be able to get an analysis from it because it is so small. Furthermore, I would say morphologically, it's not Katla, but it remains to be seen if we will ever get an analysis from that. So Michael Siegel sent us more ice, this time from Tunu, hoping to capture the same event. Unfortunately, we do have more shards, and there is even a grain there that does look like it could be Katla. The question you could ask is, okay, even if we had one grain and it did turn out to be Katla, would it be significant? And I would say, yes, it would, because we know if the chemistry matches the event and it's found at the right date, I would say that is confirmation that the event happened at that time, or that the acid in that layer corresponds to the event in question. But as I said, the concentrations of shards are generally very small. We have rather a lot of samples of just one or maybe two shards. So some possibles, we won't know if they're Tephra really until we analyze them. We have a small number of samples with more than 10 shards. It's, happy days. And some of these are the 860A, the Changbai-shan. The ones we know are quite numerous. I'll just mention some of the interesting Tephras that we're finding. One of the tie points in the ice cores has been the acid layer that has been attributed to Vesuvius 79. And the ice core workers would say, well, because we have the acid layer from Vesuvius in all the cores, we know, and we've counted down and we're at the right age, we know our chronology is exact at this point. There has been a bit of controversy about the publication of some analyses, 3 to 5 micron shards of glass found in grip that seem to match Vesuvius Tephra, and these are the dots plotted out, the points plotted out. And indeed, at least 4 of them are consistent with Vesuvius type Tephra. We looked, and we didn't find Vesuvius Tephra, but we did find Tephra, nice, big, chunky shards. And we've analyzed them, so we've got lots of points, and they most closely match Aniak type Tephra. This is consistent with the acid layer that's in the ice that increases as you go further north in Greenland, suggesting that we are actually looking at a northern hemisphere, a high latitude source for the acid layer. Michael has been working on redating the ice cores, and we think, that this acid layer doesn't date to AD 79, it dates to AD 87, so it can't possibly be associated with Vesuvius. The exact source, we have to do a bit more work to try and find out the exact source of this Tephra. Another big event that we've been looking at is the AD 536 event, not the event that Alexa mentioned earlier on, because if the ice cores are redated, your event will be 540 AD. This is the one that is a little bit earlier. It's one of 2 acid spikes, one of which is confined to the northern hemisphere. The second one is found, it's bipolar. And we've got lots of Tephra here again, morphologically varied and geochemically varied, as you can see. This was interesting, because we were delighted with these big shards of Tephra to analyze. We managed, because they're large, we can get multiple point data from each shard. So we analyzed one shard, got something, didn't recognize it, analyzed the second shard, got something different, analyzed the third shard, got something different. So far, we've analyzed 9 shards, and some of them overlap, so there's some repetition in there. But by and large, we're looking at different events represented within this, this acid layer. Now, are we to give up on these because we only have 1 or 2 points representing an eruption? Is this background noise? I don't think so. What we can try to do is find out where these were coming from and find out what was happening. 3 of the shards have characteristics that I would say are quite similar to monocraters, which had an eruption around this time. So it's plotted against the recent compilation of data that Marcus has published. It's in the right time frame. We need more analyses. Incidentally, there are more glass shards. We haven't finished analyzing this sample because we polish, analyze what's exposed, we polish some more, analyze what's exposed. So it's a progressive procedure. Other shards, again, look like Aniakchak. No known event at this time that I'm aware of, but again, suggesting that we're looking at another Northern Hemisphere event. And Steve has suggested that yet another shard may have has similarities to the Mount Tephra, again suggesting potentially a third volcanic eruption around the same time. So despite the differences in the chemistry, it does seem to be suggesting that we've got multiple volcanic events happening at the same time and contributing to this large acid layer, contributing to the dry fogs that are reported in historic records at the time, and contributing to a climatic decline as well. That's recorded in tree ring records. So, to conclude, the small number of analyses may seem problematic to people who are used to working with large quantities of tephra, but I would suggest you don't dismiss them. Don't say these are insignificant, because you need to have X number of analyses for it to be a robust data set. If we can find consistency in the data, so you've got multiple shards in a layer that are showing the same kind of stuff, if you can get replicate analyses even on single shards so that you can show that you've got robust chemistry from those individual shards, if you can find the tephra at multiple sites, well, that's best still. If you can find it at multiple sites, it is telling you there's an event. And if you can find supporting evidence, such as the dating of the tephras, then this is telling you that you're looking at real material. I should point out, we don't have volcanic ash randomly flying about the Irish atmosphere, the Irish landscape. This stuff has to cross basically, we're not near any volcanic sources. It has to be coming in from further afield. We're not finding it randomly distributed throughout the Holocene. We're finding it in the right time frames. It would be really, really helpful if there were more published data out there, accessible data, so that we can plot them again. We can plot our data against data sets rather than mean and standard deviation results. Thank you very much. I've finished. I should thank all the individuals that I'm constantly saying, can you have a look at this? Can you have a look at this? Can you have a look at this? Thank you very much, because I would make no progress without you.